Now take some time to complete these problems, and whenever you're ready, you can continue to look at the solution with me. In part 8, if we want to look at completing the square, the first thing if we want to do to find x-intercept is set f of x to be 0, and therefore x squared minus 4x minus 12 is equal to 0. And with this, to complete the square, we can move 12 to the other side by adding 12 on both sides. So 12 is equal to x squared minus 4x. And our goal is to incorporate x squared minus 4x as part of the perfect square trinomial. And that tells me I would want to have a perfect square over here. The first part will just be x, and then the second part we established that we want to do half of negative 4, which would be negative 2. Because then if we do the FOIL process, the inside and outside create the same term that would add up to negative 4x. So we need negative 2. And then we want to compare what we have over here compared to the previous step. The additional constant term we need in the trinomial comes from the last. So last times last will be negative 2 times negative 2, which is positive 4. So that means we need to add 4 on this side, which indicates we have to add 4 on the other side as well. And that gives us 12 plus 4 is 16. Now we have a perfect square, and we can take the square root on both sides. Make sure you take both positive and negative of the answer, and we get plus or minus 4 is equal to x minus 2. Therefore, 4 is equal to x minus 2, or negative 4 is equal to x minus 2. Solving for x by adding 2 on both sides, we get 6 is equal to x, or negative 2 is equal to x. Therefore, our x-intercepts are 6, 0, and negative 2, 0. Now in part B, if we want to complete the square, we have again the same beginning by letting the constant term by itself by adding 40 on both sides. So 40 equals x squared plus 6x. And from here we can think about writing this as a perfect square trinomial. So we'd have x, and we'd have half of 6, which is 3, so positive 3 squared. And thinking about what to add, it comes from the last times last, so which would be 3 times 3, or 9. Whatever we do to one side, we gotta do it to the other side, and that gives us 49 is equal to x plus 3 squared. Now taking the square root on both sides, we get plus or minus 7 is equal to x plus 3. That tells me 7 equals x plus 3, or negative 7 equals x plus 3. Therefore, x is equal to 4, or x is equal to negative 10. So that gives us the x-intercepts 4, 0, and negative 10, 0 as a result. Moving on to part C, we're still repeating the same process. We want to isolate the variable terms by themselves and the constant by itself. And altogether, you should see that 8 is equal to x squared plus 10x from here. And for the trinomial, we need x to start, and half of 10 gives us 5 squared. And compared to what we started with, the last times last would be 5 times 5, which is 25. So plus 25 on both sides. And that gives us 33 is equal to x plus 5 squared. And now we can take the square root on both sides and get plus or minus root 33 is equal to x plus 5. And therefore, our x is equal to plus minus root 33 minus 5. And the x-intercepts will be root 33 minus 5, comma 0, or negative root 33 minus 5, comma 0 over here. Then for part D, we again start off the same way. Because we want the whole thing equal to 0, we can just move the constant term to the other side by subtracting 2 on both sides. Get negative 2 is equal to x squared minus 6x. And then to complete the square, x to start, half of negative 6 becomes minus 3, because the inside and outside again, minus 3x gives us minus 6x. We want it to be a perfect square. And then we want to think about what's the additional term we have to add. It comes from last times the self. Negative 3 times negative 3 would be positive 9. So we're going to add 9 on both sides, and that gives us 7. And this becomes very similar to what we did in part C by taking the square root. We are going to get the result that plus minus root 7 is equal to x minus 3. Therefore, x is plus minus root 7 plus 3 equals x. And in case you're wondering why I didn't write parts C and D into 2 equations, that's because I can't combine the square root with the other constant term anyways. That's why I didn't bother writing out 2 linear equations like I did in parts A and B. In parts A and B, because they're all integers, I can combine them. Here I have a square root value that cannot be simplified and an integer. They can't be further simplified by combining each other. That's why I just left it there and write out my solution like this. And these are the 2 values that we would get for the x-intercept. And now for the last 2 problems, parts E and F, we are again working with problems where the linear coefficient is an odd number, so we will be working with more fractions in parts E and F, but the process is the same. We again set the whole thing to be 0. If we want to get the constant by itself, we would get x squared is equal to negative 5 is equal to x squared minus 3x. And to complete the square, I again want to think about what's half of negative 3x to create it. So we would get minus 3 over 2 squared to create a perfect square. And then if we want to think about what number to add, we are just multiplying the last in the FOIL process. Negative 3/2 times negative 3/2 gives us positive 9/4. So we would have to do plus 9/4 on both sides. And hopefully by this point you notice this already. Negative 5 plus 9/4 is going to be some negative value over here. And if we have a perfect square and we have this value being less than 0 over here, we know this equation won't have any real number solutions, so we can say there is no real solution because any perfect square should be greater than or equal to 0. So there is no x-intercepts for our quadratic function. And next, for part F, when we have this form, we want to repeat the process as how we started in part E. We can add 7 on both sides and get 7 is equal to x squared plus 3x if we know L of x is equal to 0 for the x-intercept. And from here we can go ahead and rewrite the right hand side to be x plus 3 over 2 squared. And to find out what number to add, we want to square the 3 over 2. So 3 over 2 times 3 over 2 again is 9 over 4, which is the same as how we started the last problem. And now we have a positive value on the other side, so we need to simplify it a little bit. So 7 is really equal to 28 over 4 plus 9 over 4. So in this case, when we combine them, we get 37 over 4 is equal to x plus 3 over 2 squared. To find x, we need to take the square root on both sides, plus or minus. And on the left side, square root of 37 over 4 can be simplified a little bit. Square root of 37 stays the same, but root 4 becomes 2. and that's equal to x plus 3 over 2. And therefore, to find x, we can subtract 3 over 2 on both sides. So root 37 over 2 plus or minus, then subtracted by 3 over 2 is equal to x. Therefore, to list the x-intercepts, we would have root 37 over 2 comma 0 minus 3 over 2. So you can combine them. Or we can have negative root 37 minus 3 all over 2 comma 0. And these are going to be our x-intercepts for this quadratic function.